Hi, let's look at an example with energy and voltage. In this circuit, we're given 3 resistors and a current source to drive current through all 3 of them. As a matter of fact, that same 5 milliamp current source is flowing around the entire circuit. So at a certain point later on in the example, it's going to be very beneficial for us to know the current through each of those resistors. It's 5 milliamps. We're also given the information about the energy, the U sub A, U sub B, U sub C, and U sub D. That's the energy at each of the 4 corners of the circuit, labeled as A, B, C, and D. What we're asked to find is the voltage at each of those 4 corners, and then also the voltage across each of the 3 resistors, and ultimately what is the value of each of those 3 resistors. So let's go ahead and do that. It may not seem like we have enough information, but it turns out that we definitely do. The one piece of information that's not in the circuit diagram is here in the problem statement, and that is that it's a 2 coulomb charge. Because remember that the definition of the voltage, so let's say for example V sub A, is going to be the energy at that point divided by the amount of charge that is at that point. So U sub A divided by Q. So this is going to be 10 joules divided by 2 coulombs, which it turns out is 5 volts. We can write the same sort of equation, V sub B is equal to U sub B divided by Q, which is 7 joules divided by 2 coulombs, which is 3.5 volts. V sub C equals U sub C over Q, which it turns out is 4 joules divided by 2 coulombs, or 2 volts. And then finally V sub D, the easiest one, is U sub D divided by Q, but U sub D is just 0 joules. So 0 joules divided by 2 coulombs is 0 volts. Now I know that in your experience with physics classes, it's much more common for you to have information about the energy in joules. But as a circuit analyst, it's very weird to get information about energy in joules, because that, of course, depends upon the amount of charge. It's much more common for us to work with voltages. And so as a circuit analyst, I'm much more comfortable now that we have the information about these four voltages. Now we can tackle the rest of the problem. No challenges really left. So V sub R1 is the voltage that's across this first resistor. It's between node A and node B. And you'll notice that the positive sign, the positive terminal on the polarity indicator, is toward node A. So therefore, V sub R1 is going to be V sub A minus V sub B. V sub A is positive because it's at the positive terminal. V sub B is negative because it's at the negative terminal. And therefore, this is 5 volts minus 3.5 volts, which is 1.5 volts. So that's the voltage difference across the first resistor. V sub R2, you'll notice that that's between nodes B and C, with the positive terminal more toward B. So this is V sub B minus V sub C, which it turns out is going to be 3.5 volts minus 2 volts, which is 1.5 volts. Just a coincidence that those two numbers happen to work out to be exactly the same. V sub R3 is between node D and node C, with the positive terminal more towards C. And so therefore this is V sub C minus V sub D, which is 2 volts minus 0 volts, which is 2 volts. So we now know the voltage across each of the 3 resistors, and then our job remains to calculate the resistances. Well, we know from Ohm's law that V is equal to I times R, but a more useful version of that equation in this case is that R is equal to V divided by I. Because it turns out that we know the voltage across each of those resistors, and remember from the beginning, we know that the current through each of them is also 5 amps. So therefore R1 is going to be V sub R1 divided by I, which is 1.5 volts divided by 5 milliamps. And that works out to be 0.3 kiloohms, or probably more commonly we would write that as 300 ohms. So now we found the first resistor. R2 is going to be the same. This is going to be V sub R2 divided by I, which is still 1.5 volts divided by 5 milliamps, which is 0.3 kiloohms, which is 300 ohms. And then finally R3 is going to be V sub R3 divided by I, which is going to be 2 volts divided by 5 milliamps, which is 0.4 kiloohms, which will be 400 ohms. So again, at the beginning, it might have seemed that we didn't have enough information to solve this entire problem, but as it turns out, we had enough information. Between the energies, the charge, and the amount of current that was flowing, we had enough information to solve the entire problem. Thanks for your attention.